Hello, everyone. Andrea, thank you. Thank you for presentations by Pablo and Dr. Derzy. It is an honor to be here and to present how we do standardization of distributed solar operation with industrial IoT. I will talk about two main topics. One of them is how should we promote best practices? But also I would like to talk a little bit how we can achieve it with industrial IoT technology. I will start with a small slide, which is talking about the rapid growth of solar PV, which has already been discussed previously. So we have this grand capacity of solar power coming online worldwide. But I think an important message is that we have also a lot of distributed PV in this chunk, and we're now roughly talking about 15 million facilities worldwide, mainly in OECD countries. You can see that US alone, with its roughly 103 gigawatts, is more than 2 million systems, and there are of course millions more in other countries. So this has held a lot of solar units, and we are going to have great many more over the coming decade, tens of millions of more actually. And this is how it looks like. So this is commercial solar PV on rooftops. Residential scale looks of course smaller, but it's also on rooftops. And overall distributed is everything in general which is below 1 megawatt. So it's both rooftops, but also some smaller land-based facilities, which are industrial scale, and covered reservoirs and other things. Now, the thing with distributed PV, as mentioned by Dr. Derzy, is that you have some kind of equilibrium. Now, you know that the performance reduces with time, and you know that you need to perform O&M to keep it. So in best case scenario, you are where the blue line is. It means degradation of around 1% per year. In hotter climates, it goes a little bit higher, around 1.3 or 1.4. In utility scale, it goes a little bit lower, somewhere around 0.7. The thing is that in real life, we rarely see this kind of degradation. In distributed PV, what we see typically is around 1.5%. And this is still with professional O&M. This is not bad, considering that the costs of O&M are affordable. But the thing is that if you are going to a mature O&M, meaning not professional one, your system performance is aging very fast. And this is the orange line. Now, the worst case scenario is the red one, meaning that you neglect your system. And this is a typical case when the system is not connected to the cloud, you cannot monitor it, and the degradation rates are pretty high. We often see systems which are degrading by nearly 50% after just one decade. The thing in research about those facilities is that typically what is being analyzed are those who are connected to the cloud and do have professional O&M. So you typically see reasonably good numbers. But when you also account for all those which are not connected to the cloud, things begin to look quite different. Now, imagine also that in order to achieve this blue line or green line, you need to invest money in O&M. And of course, the more money you need to invest, the less profitable your facility becomes. But what is obvious is that if you are somewhere between orange and red, you are not profiting from your facility at all. So you need to be very careful with tariffs on solar electricity. And here net metering certainly is a very good thing. And O&M has to adjust to lower tariffs or lower costs of solar electricity. And this should take time. You cannot change it very fast. So what is solar PV management? Like, what is O&M? We're typically talking about, first of all, operation and maintenance, but also supervision and financials. We mainly concentrate at Soltell in automation of operation, but we also do supervision, and we also do predictive maintenance to some degree. To this sense, we also have complementary lectures after me, which will talk about automation of maintenance by RST and what can be done in the financials by Blu Banyan. Now, how it works. So essentially, the way things work is that there is an operational team at an integrator company, which takes care of O&M, and they typically manage a certain amount, a certain quantity of facilities. They typically use quite several software tools for monitoring. They also use a different software tool for task management and sometimes another software for weather prediction. And they combined all this data with a lot of Excels and using emails and phones for communication. And this works to some degree, but let me show you some things which occurred over the past decade. So we saw a significant change in the number of facilities connected to the grid, actually in the percentage of them. And the number of facilities managed by each integrator company increased by nearly tenfold. Now, we also see more brands of inverters, meaning more software to monitor them. And we also see panel level monitoring, meaning more data needs to be analyzed. Now, overall, we're talking about an increase of data 240 times. And the same people need to process it, so you already begin to understand the problem here. An additional thing, which in addition to managing all this data, is also whether you can decrease the costs. The costs, unfortunately, remain pretty much flat over the past several years in distributed solar O&M. And in US, for example, it's about $19 per installed kilowatt per year. But this doesn't include also other things, which are, for example, supervision and training of the staff, and neither also financials. So you are pretty much expensive O&M costs and you want to go lower. And I will talk about it shortly. Now, what has been done about best practices? So quite a lot of questions can be put here on the table, and some of them have already been assessed by various organizations. Here you can see reports by some of them. But essentially, there are two things to take care of to bring O&M to everyone. One is to unify the standards and to bring O&M standards to everyone to know what they're buying. Meaning a person or a company who is buying O&M services in one place, he will know what he's buying, and there will not be a different way of operation and a different kind of contract everywhere in the world. And another thing that we also have to take into consideration the costs. So I will show you some examples here, what we're talking about. Here, for example, you see a pretty much standard monitoring example of a solar facility, a commercial scale. We're talking about a 2-inverter facility. And in this case, one of the inverters started in the morning without production. Essentially, that's probably a problem with the switches. Now, a standard O&M procedure would be to check this facility once a day. By the way, some of the software tools do have automation. I have to mention, for example, Fronius, and we do have some Fronius professionals here in the crowd. So they will typically get an automatic report later that day, but that's not sufficient enough. And typically, we would like to see a more real-time response. So the team will typically take note of this about once a day, but it depends how many times a day they do the monitoring. Now, what we do, for example, with Industrial IoT approach is we can basically control how many times a day we do this performance analysis. And then in this case, this is actually one of our connected facilities. Already at 10 a.m., it was understood that there is a problem in the inverter, and the customer received an SMS. And around noontime, he already managed to do something with the facility. And you can see an actual correspondence with him. He received an automatic mail and responded to it as if it was a person. Now, you have to understand that in our approach, no person was ever employed during the whole process, except the actual approach to the facility and turning on and off the switches. Another example I would like to show you is a little bit more sophisticated. And this is how daily monitoring of power looks like at a single inverter facility. And we see more and more single inverter facilities in the commercial scale, and of course in the residential scale. So this is not so much an issue for when you have panel level monitoring, but this is when you have commercial scale without panel level. And to understand that you need to find about 10 to 25% of power reduction when you have a weather variation, this is something which is pretty hard and requires quite a lot of training. So making sense out of this chart, you can understand it's pretty hard. You have to be really trained and really experienced. But we think, first of all, that training could be quite important here, and a certain standard could be important. But for example, I've seen quite several contracts where the integrator commits to find a deviation of 10% in production. But you can clearly understand that it is not possible here with human monitoring. Now, on the other hand, if you do have more advanced tools, you can do it by evaluation of the uptime of the facility. And you can see here on the chart that it's clear that on the 19th of November, this facility went down by 25% in production. And this is, of course, an automatic assessment. The third example I want to take and show you what happens with the noise. Now, even when you do have automation in monitoring, the question is what you do with this data. And you remember, you have a lot of data. So when you have a lot of facilities and a lot of data, we have operators who are simply drowning in it. Now, for example, in this case, you have a facility which experienced several grid disruptions. And this produced quite a lot of tickets, quite a lot of alerts. But essentially, nothing important has happened here. And you need to understand that moving from qualitative assessment, when you know there is a problem, but you don't know how much it costs, to a quantitative assessment, when you know that how much the problem costs exactly, is a very big difference. So in this case, for example, the cost is very insignificant and there is not much you need to do about it. And that's the difference between the manual approach, using the existing tools, and the industrial IoT approach. The last example I want to show you is actually what we can do also with assessment of soiling. So naturally, you cannot assess soiling just with monitoring. You need something much more sophisticated. You have some hardware tools for that. Let's be clear about it. But it has been pretty much proven that those cannot be implemented widely in distributed solar. It costs quite a lot of money just to maintain them on every roof. So en masse, it doesn't work. And if you do have a software solution for that, this works much better. So you basically have one solution, which is a satellite-based, and another, which is our technology, which is the SWMT. And you can see that this works pretty fine, and we can quantify dust very efficiently. So essentially what we provide at Soltell, we provide efficient tools for managing hundreds and thousands of facilities. We do it as white labeling, and we don't require any additional hardware. And this essentially allows us to reduce operation costs significantly, faster response by the maintenance teams, and also reducing supervision. This is relevant for regional authorities and governmental solar. And we also reduce maintenance by nearly 40% using predictive maintenance. So we already operate in Israel, recently in Poland. We manage quite several percentage of Israeli facilities. And we plan to start operations soon in Germany, and as well as in California in the US. We work with the integrators and regional authorities, and you're welcome to ask me any questions. Thank you very much.
Thank you so much, Leon. There was definitely some very valuable insight there.